Welcome to ClickMyProject.com. Now we discuss about the product for Drowsy driver reduction using representation learning. Next we see the abstract for the product. Drowsy failure is a significant factor in a large number of vehicle accidents. Facilitate have occurred to the result of car accidents related to driver inattention, such as the dissociation and fatigue and lack of sleep. Studies and experimental have sustained the fact of driving performance determinates with increased drowsiness. The US National Highway Traffic Safety Administration has estimated approximately 1 lakh crashes each year caused mainly to the driver fatigue and lack of sleeps. Autonomous system designed to analyze the driver exhaustion and detect the driver drowsiness can be integer part of failure future intelligent vehicle so as to prevent accident caused by sleep. A variety of techniques have been employed for a vehicle driver failures and exhaustion detection. Driver operation and the vehicle behavior can be implemented by monitoring the steering wheel movement, accelerator and brake patterns, and vehicle speed and lateral acceleration and lateral displacement. These are the non-instructive ways of the drowsy driver detection, but the limitation to the type of vehicle and driver conditions. Another the set of technique focused on monitoring of physiological characteristics of the driver such as the heart rate, pulse rate and the electrostechnography. Research in these lines have suggested in the alertness level decreases the ECG power and alpha theta bands increases. Hence the providing indicator of drowsiness. Although the although the use of these physiological signal yield better reduction accuracy, these are the not accepted widely because they are less practically. The third set of technique is based on the computer vision system, which can recognize the facial appearance changes occurring to the during drowsiness. Physiological feature based approaches are incentive because the measuring equipment must be attached to the driver. These are the vehicle features based approaches has been recently becomes the preferred because of their non-instructive nature. In this paper, we propose a new scheme-based extraction and visual features from the data without human intervention. These are the visual features have been learned using the model of deep learning known as the conventional neural networks. These feature maps produced the convolving the learned weights within the input image act as the feature for driver drowsiness detection. Using these set of the features, a softmax layer classifier is used to final classification the frame extracted the drowsy and non-drowsy. The advancements of the computing technology over the years has provided assistance to the driver mainly in the form of intelligent vehicle system. Driver failure is a significant factor of large number of vehicle accidents. This driver drowsiness detection has been considered the major potential area so as to prevent of huge number of sleep-induced road accidents. This paper presents a proposed a vision of based intelligent algorithm for detect the driver drowsiness. Previous approaches are generally based on the blink rate and the eye closure and the yawing and eyebrow shape and the other hand engineered facial factors. The proposed algorithm make to use of the features learned using the conventional neural networks so as to explicitly capture various latent facial features and complex nonlinear facial feature interaction. A soft max layer is used to classify the driver and drowsy or non-drowsy. This system is hence to for warning the driver drowsiness or inattention to prevent the traffic accidents. Next we see the flow diagram for the product. Browse the first given input for the driver images and to apply the filter function. This input filter function to apply the median filter to filter the general AWG noises and remove the overall image and to crop the face image only and resize the selected cropped image. These functions to be applied by the MATLAB 2013 software and these output to be write into the any one of the text and to apply the Xilinx software. The Xilinx software to be get into all the text and to identify the feature extraction transform. Feature extraction transform, we use the local binary pattern based on the our feature extraction transform and apply the DWT feature extraction for the original original information identification for overall selected cropped images. Then apply the classification architecture. This classification architecture to be represent the Gaussian kernel unit using the RP or multiplier architecture. Gaussian kernel unit to be identify the minimum distance for overall test vector and support vectors, and the codic exponential processing element is to reduce the exponential unit functions for apply the codic input function. Then function to be satisfy the f power based on the our overall codic functions. Then to apply the scaling unit operation. The scaling unit operation to represents the overall support vector and the selected test vector. This support vector test vector to be set in the any one of the threshold level value. We apply the threshold level to be 4 and to selected the minimum distance variation for test vector and support vector. If the condition to be satisfied, to be selected the S position and the no position. This select the S position to be identify the our required Drowsy driver image which person detail to be identified using the MATLAB, using the Xilinx software. These all function to be identified the Xilinx 14.2 software. Finally, we see the output for the product. First, we run the main function. This function to be selected the any one of the face image for Drowsy driver based selector. This is the driver data set. These are the different normal position and abnormal position based all images to be identified. We select the any one of the image and to filter this image selected image and to selected the cropped images, and automatically open the Xilinx software. This software to get all the values from the text using this type of text values. The text values to be identify all the information about our received selected face images, faced crop images. Then to select the code for the feature extraction architecture. This feature extraction architecture to be selected all the values from the code. This identify the overall information based on the feature values and to select all the feature values and to apply the MATLAB again. So the feature values to be completed and we go to the classification process. Then to run the classification architecture. Again we open the Xilinx software and we run the classification architecture and to finally identify the image positions. Then to run the classification architecture. This is our the classification process. Finally, we identify the person details for selected input images. These are the information about our required architecture. Then to apply the clock sequence and to identify the character value for representation for Drowsy position, Drowsy driver position. These are the abnormal position for our selected input image for overall data set. These are the final output for our the product.